All right, so if we go over the warm up, so basically all three of these problems will give you either irrational solutions or they would just be fractions or something besides just straight up whole numbers like we were dealing with yesterday. All right. So, first things first, number one, before we can do anything, we got to get one side equal to what? 0. So, we got to subtract the 10x over first. That goes away. I get x squared minus 10x plus 6 is equal to 0. Now we can move our constant over. So I subtract the 6 to both sides. So guys, I would write this off to the side, like on that blank side, just so you, even if you did it wrong, you have the correct notes on there, okay? So this would be x squared minus 10x, big space, is equal to negative 6. Then we do what? B over 2 squared, so negative 10 over 2 squared, so that's negative 5 squared, which is 25. So we would add 25 to both sides. This would be x squared minus 10x plus 25 is equal to 19. Then we factor by the trick. So square root of the first and last term, keep the sign of the second. So this will be x minus 5 squared is equal to 19. Now I'm in solving mode. So what do I do? Square root both sides. Now, this is where some of you miss this part, but even if it's not a perfect square, you still got to put the plus minus in front of it. So this would be plus or minus the square root of 19. And then the last thing you would do is add the 5. So this would be x is equal to plus or minus the square root of 19 plus 5. Or you could write it as 5 plus or minus square root 19, either way. And since we can't simplify it any further, that's your answer. Because remember, we could separate into 5 plus square root 19 and then 5 minus square root 19. But since we can't simplify it any further than that, we can just leave it as the shorthand. So that was one where you got an irrational solution. So all the ones we did yesterday were rational. This one was an irrational. Now, you may get thrown one of these on your test. So you may get thrown an irrational solution on your test. All right. Now, the next one. This is one where the A value is not 1. So I at least want you to see one of these. Plus, you needed one for your one pager anyway. All right. So remember, your first step is to just go ahead and get rid of your C value. So I'm going to subtract the 90 over. So I would not factor first. I would get rid of your C value first. Now, I need to get my A value as 1. So what do I need to do? Factor a 2 out. So I'm going to leave this as 2 times x squared plus 16x, leave a space, it's equal to negative 90. Then I do my b over 2 all squared. So that's 8 squared or 64. So I'm going to add 64 to this side. But what am I adding to the other side technically? 128. You got to multiply the 64 by 2. All right. So this will be 2 times x squared plus 16x plus 64 is equal to 18. Correct me if I'm wrong. It's 19? Okay. You sure it's 19? Negative 90 plus 128. I'm pretty sure that's 18.
That's 38.
It says 28. That's a 2.
Yeah, 128
Uh-huh.
minus 90.
Uh, 38. Okay. I was about to say, it has to end in an 8, not a 9.
How do you get 128?
Yeah.
How do you get 128?
You have to multiply 64 by 2. Yeah. All right. Then, yeah. So then we would factor. So this would be 2 times x plus 8 all squared is equal to 38. Now remember SADMEP. So before we can take the square root, we'd have to do what? Divide by that 2. So that goes away. I get x plus 8 squared is equal to 19. I did not intend for both of these problems to have the square root of 19, but here we are. Then take the square root of both sides. So x plus 8 is equal to the square root of 19, plus or minus in front of it. And then finally, we would subtract the 8. So this would be x is equal to negative 8 plus or minus the square root of 19. Or you could have written it as plus or minus square root of 19 minus 8. Either way. Now, this last one, I intended for you to solve it. It used to be a multiple choice problem in Delta Math. I just took away the multiple choice. So, now, with completing the square, as long as there's a constant on the other side of the equal sign, you don't necessarily have to get one side equal to 0 to start with. All right? But, like with our first one, since that value had a variable, we had to subtract it over. But since this negative 7 right here is a constant, we don't need to subtract or add it back over to the other side. We just need to add this 7 to the other side to start. So this would be x squared minus 3x is equal to 0. Now, what's going to be the big issue here? What's my b value? It's odd. So what's going to happen when I divide by 2? It's going to be a fraction. All right. So this would be negative 3 over 2 all squared, which is just what? So remember, this is the same thing as negative 3 squared over 2 squared. So this would be 9/4. I want it as a fraction. So I'm going to add 9/4 to both sides. So this would be x squared minus 3x plus 9/4 is equal to 9/4. I wouldn't, but I prefer fractions. Because honestly, they're not hard to find as a fraction anyway. Square the top and the bottom. So you square the negative 3, you square the 2. So I'm going to square root the first and last. Keep the sign of the negative. And remember, square root of 9/4, you're square rooting the 9, you're square rooting the 4. So this would be x minus 3/2 squared is equal to 9/4. Can take the square root of both sides, that goes away. I get x minus 3/2 is equal to plus or minus 3/2. And then we add the 3/2 to the other side. Now, this is technically rational solutions because even though it's a fraction, they're nice fractions. It's in halves. So that has an ending decimal, so it's rational. So we do have to separate that answer. So we have plus or minus 3/2 plus 3/2. I can then separate that into positive 3/2 plus 3/2, which is 6/2, or what's that? 3. And then negative 3/2 plus 3/2, which is just what? 0. So x is equal to the set of 0, 3. So, like I said, I just wanted you to see some of the harder ones. And again, if these were on your test, they'd probably be a bonus question. I'll give you more easier ones on the test. But some of you are saying, like, what do I do about the completing the square where a is greater than 1? Well, there's your example right there that you can put on your one-pager. All right, any questions on that? Okay, so hold on to that paper because we're going to come back to it because we're going to do the backside together in a little bit. But the next thing that we're going to do, so take out your packet and go to page 26. All right, so our last lesson for this unit. So remember, your test is going to be Monday. All right, that's why I went ahead and gave you your review because I know tomorrow's a half day. So you should have your review. I'll post that key later. All right, but so the quadratic formula is probably the most relevant way to solve a quadratic because it works for any quadratic. All right, now if we look at 1 through 4, all right, just at a glance, let's figure out how we would solve these. Like, we're not going to actually solve them. We're just going to see what the most effective method to solve is because some methods are easier than others. All right. So for number 1, what would be a fairly easy method to solve that? So of all the methods we've learned so far, what would be a good method to solve number 1? You could do completing the square, but there's an easier method because I don't want to deal with that. You could factor. So this one is factorable, so you could solve by factoring. You could do completing the square as well, but it would be harder because of that odd b value. What about 2? So how have we solved 2? So you could do it either by factoring the difference of squares, which you said DOS. Yeah, okay. I thought you said dot. I was like, okay. Or what's the other way you could do it fairly easily? Couldn't we solve this by taking a square root? We just have to divide the 4 over square root it. Can we do that? So we can also do this by taking a square root. What about 3? What's the easiest way to solve 3? Taking that square root. Now, the last one. What's the only method that we know so far that'd be fairly straightforward with solving that last one because it's not factorable? Completing the square. So CTS is just my shorthand for completing the square. Now, like I said, completing the square isn't necessarily hard, but it can get dicey sometimes depending on the numbers. So completing the square will work for any quadratic as well. But there's actually what I feel as an easier method or more straightforward method, which is the quadratic formula. So my preferred method, when in doubt, if I don't know how to solve it, I can't figure out if it's factorable or not, I don't know if I should take a square root. When in doubt, quadratic formula. All right. It is the universal way to solve a quadratic. It works for any quadratic, whether it gives you a rational number, irrational number, or an imaginary number or complex number. Now, little review. So let's just list our A, B, and C values. So remember, if you start with x squared plus ax squared plus bx plus c equals 0, that's your standard form. We're going to list our A, B, and C values because you'll need this for the quadratic formula. So what's my A value for number 1? B? C. All right. Now, if you were to take the discriminant, so remember, the discriminant formula is right here, b squared minus 4ac. What would your number be? So if I did negative 5 squared minus 4 times 1 times negative 24. Just stick that in your calculator real quick. What would you get? Don't forget to put parentheses around the negative 5 squared. 107. Which, what does that number tell me about my type of solutions? 2 real. So we would have 2 real solutions, which makes sense because if we factored it, we would get 2 real solutions. All right. What about number 2? So what's my A, B, and C value? What's A? 4. What's B? 0. B is always connected to an X value. All right. So if there's nothing there, 0 is the number for it. And then negative 9 is your C. So A is always connected to your X squared. B is always connected to X. C is always your constant. Always. So if we find the discriminant, 0 squared minus 4 times negative 9, what would that give us? 144. So what does that tell us about our solutions? 2 real. All right. So 1, 2, negative 20. That's our A, B, and C. What would the discriminant be? So this would be 2 squared minus 4 times, yep, which will give you what? 84. So what type of solutions do we have? 2 real. And then our last one would be 1, negative 6, and 1 as your A, B, and C. So this would be negative 6 squared minus 4 times 1 times 1. So what would that be? 32. So that would also be 2 real. So all these would give us real solutions, but number 4, we would have to do completing the square or quadratic formula to get there because it can't be factored. Now, before we actually get into quadratic formula, I want to actually tell you guys how it's derived. All right. So quadratic formula actually comes from completing the square. All right. So without telling you what the quadratic formula is first, I'm going to actually derive it. So whenever we start with the quadratic formula, we always start with ax squared plus bx plus c is equal to 0. Now, we're going to derive this by using the completing the square method. All right. So we would subtract our constant over first, like we always do. This would be a x squared plus bx is equal to negative c. Now, when we complete the square, what does our a value always have to be? 1. However, we don't know what a is. So how can I guarantee that a would be 1? You can either factor it out, or to make our lives a little bit easier, we could also just multiply this entire equation by 1 over a. All right? Because what it does is that when we multiply by 1 over a, it would, first off, take this a away, making that x squared 1. And whatever you do, you can multiply anything you want to an entire equation as long as you keep everything balanced. All right? So this would be x squared plus bx over a, something is equal to negative c over a. And again, why I did that instead of factoring it out is that we would have ran into the issue later with dealing with some really weird fractions once we started moving stuff around the equal sign. All right? Now, what do we do next? So how do I find what goes here?
B over 2 all squared.
B over 2 all squared. So I want to make this, so this would be b of x over a all over 2 squared. Now, if you're dividing something by 2, that's the same thing as multiplying it by what? 1/2. So this is the same thing as b of x over a times 1/2, which is b of x over 2. And then we square it. So remember, you always square the first, you square the top, and you square the bottom. So we're going to distribute the 2 to all 3 of these. So this would be, oh wait, why did I put that next? So this would be b squared over what? Okay. 4. So it probably helps if I put this. Over 2a. Sorry. So this would be b squared over 4a squared. So plus b squared over 4a squared. Now remember, whatever we do to one side, we gotta do the what? Other. All right. Now,
How did you do 4 instead of 2?
because we have to square the 2 as well. So remember the power rule? If you have b over 2a all squared, you gotta you gotta distribute the square to all of the bases. So it'd be b squared over 2 squared a squared. Simplify that before. All right, now from here, we would actually factor it. So, square root of the first, square root of the last, keep the sign of the second. This would be x plus b over 2a squared is equal to negative c over a plus b squared over 4a. All right, now, before we deal with solving by the square root, I actually want to simplify this side a little bit. So if I add fractions, what do I always need? Common denominator. So couldn't I change this to have a common denominator?
Yes.
Yeah. So all you would have to do is multiply the top and the bottom by what?
4a.
4a.
You just said 4. I did 4a. No, it's not.
All right, so this would be negative 4ac all over 4a squared plus b squared over 4a squared. So that would give us negative 4ac plus b squared all over 4a squared. All right. Now, I'm actually going to rewrite the numerator so that the b squared is in front, so we don't have to deal with that negative in the front. All right, so you can just rearrange the terms, it doesn't matter. Because addition is cumulative anyway. All right, and it's still equal to x plus b over 2a. Right. No, you don't have to. It's just for fun.
Wait, you're just trying to show us. Does that? You're trying to show us where the formula comes from, right?
No, this is not how you would actually use the formula. I'm deriving the formula. So what derive means is I'm showing you where it comes from.
Yeah, it's really confusing.
So guys, essentially in mathematics, formulas always come from somewhere, and more often than not, you're deriving them. All right. So just to kind of recap what I've done so far, subtract the c over. All right. We're just completing the square. This is all completing the square. All right. So subtract the c over because that's our first step for completing the square. Then we would times it by 1 over a, our entire function, because you can do that in an equation. As long as you can multiply anything you want to an equation, as long as you multiply to everything in the equation, including what's on the other side of the equal sign. And the reason I'm multiplying 1 over a is because if you divide a by a, what do you get? 1. So I need that to be x squared so I can complete the square. So that's what I do. I did b over 2 all squared, so it was b over a, because that's what's in front of the x, all over 2. And remember, divide by 2 is the same thing as multiply by a half. So this would be b over 2a all squared. You would square every piece of what's in the parentheses. So it would be b squared over 2 squared, a squared. So that would be b squared over 4a squared. Whenever you add to this side, you got to add to this side. If I factor it, so square root everything, sign of the second, you get x plus 2a, because we basically just undo what we just did over here, squared. Now, I want to simplify this side so I'm not left with ugly fractions. I just want it as one fraction, so that's why I converted the negative ca to have a denominator of 4a squared. All right, because you can do that in math. You can change denominators as long as you multiply it. Because think about it, if I simplify this down, I would end up with what I started with. So I multiply the top and the bottom by 4 over a, because that's how I get the common denominator over here. Once I did, I just added them together so I combine them. Now, I rearranged the terms, but I can still do that because negative 4ac plus b squared is the same thing as b squared minus 4ac. It's still over 4a squared. All right, kind of getting it a little bit? Well, we're just going to keep on trucking. All right, so we then square root everything. So this is x plus b over 2a is equal to. Now, you can rewrite this as, so this whole expression we can rewrite as the square root of b squared minus 4ac all over the square root of 4a squared. So we talked about that when we did denominators, when we did simplified rationals. All right, so if I square root this, we can't undo anything in here, but we would have plus or minus the square root of b squared minus 4ac all over square root of 4 is 2, square root of a squared is a. Okay. And then our last step to solve for x, we just subtract b over 2a over. So what we end up with is x is equal to negative b over 2a plus or minus the square root of b squared over 4ac all over 2a. Now, since they both have the same denominator, I can just write them as one fraction. All right, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, my friends, is the quadratic formula.
Thanks. Is that all we have to remember?
Yeah.
I'm confused.
Guys, long story short, this is the quadratic formula. This is what you got.
Is this on a present?
Not this, just this. So this is the actual formula. They're really everywhere. Quadratics, that's easy. So any STEM job you will ever have will deal with this. Now, again, do you need to know this part? Nah. Did I want to show you it because I wanted to show you where the formula came from? Absolutely. Because how many times have you guys ever been given a formula and you have no clue where it came from? All of them, exactly. Well, now you know where the formula comes from.
It comes from the mathematician's brain.
Listen to Danny, listen to Danny.
Yeah, the NC test people.
Oh no, this came from someone way back in
Ancient.
ancient.
To figure out that's where.
So, guys, so this would be how you would derive the quadratic formula. And again, I just showed you it just so you would know where it came from.
So we
okay?
don't have to use
I mean, you gotta use this formula on math problems for help too. Alright, so now you know what the quadratic formula is and where it comes from. Let's do some problems with it. So, shh. So factoring works when your discriminant is positive. Guys, shh, back to it. So factoring works when your discriminant is positive. Roots work best when it's positive. Well, not positive. It works best when it's 0. Otherwise, we would use quadratic formula. And honestly, even if it's positive or 0, it still doesn't guarantee that it'll be a nice problem. All right. So we always start with a squared plus bx plus c equals 0. You always got to start with that. Now, you have to remember this. This is the quadratic formula. You will see this so many times in high school. You will see it in Math 3 again. You'll see it in whatever other class you take. So if you take pre-cal, you'll see it there. If you take calculus, you'll see it there. This formula you need to live and breathe by. Now, it is a big formula, so there are ways to remember it. So there is a song. Oh yeah, there's a song. There's actually 2 songs to remember it. All right. Yes, I can sing the song. All right. So basically, there's 2 versions of the song. You can either sing it to Pop Goes the Weasel or Are You Sleeping? So I usually do the pop goes the weasel one. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's all it is. All right. So that just helps you remember it. But you got to know that quadratic formula. Because, like I said, the quadratic formula can work for any situation. So if you have no clue how to solve a quadratic, but you know the quadratic formula, you can solve the quadratic.
How do you learn this song? Is there like a video? Yeah, I feel like when I can watch, it'll help me like remember.
So the other one is Are You Sleeping? So it's negative b plus or minus squared square root plus or minus square root b squared minus 4ac b squared minus 4ac all over 2a all over 2a. I mean, it like I like the other one better, but yeah. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's just pop goes the weasel.
Oh, is it that?
I really think that was the situation.
All right. So if you look at this, we got, this was the one that I said completing the square we would have to use. But if you look, we did get a positive solution. The only problem is that if we graphed it, look at what we get. Those are technically irrational numbers. So our solutions would be irrational. Now, remember what I said at the beginning of this unit. We no longer accept rounded decimals. All right, unless they specify. So whenever you're solving a quadratic, we want the exact answer, and that's where the quadratic formula comes into play. All right. So, and we're going to skip this. All right, let's look at this problem right here. Now, the quadratic formula is most helpful if your quadratic expression is prime, which is just a fancy way of saying not factorable. All right. But you can still solve any quadratic with the quadratic formula, regardless of if it's factorable or not. But if you could factor it, it's easier. So we're going to look at an expression, and we're going to solve it in two ways. So we're going to solve it first by factoring, so we can kind of get an idea what our solutions are going to be. And then we're going to solve it by the quadratic formula. All right. So first off, if we solve this by factoring, what's our first step? So we do our big X. We're solving by factoring. So that's what y'all took that quiz on the other day. So it'd be negative 12 on top, 11 on the bottom. So what adds to 11 multiplies to negative 12? Negative 1, positive 12. So we would split up the 11x into 2x squared minus 1x, or just minus x, plus 12x minus 6. Then we factor by grouping. So this would be 2. This would be x times 2x minus 1 plus 2, not 2, 6, plus 6 times 2x minus 1. Am I crying? Nope. So what are my two factors? X plus 6 and 2x minus 1. Still equal to 0. So what's my last step to solve? Set it equal to 0, both factors, and solve them separately. So x equals negative 6, and x will equal positive 1/2. And again, I'm just skipping the steps for solving a two-step equation because you guys should be fully capable of doing that on your own. So x equals the set of 1/2 and -6. Now, will the quadratic formula be the easier way to do this? No. If it's factorable, I recommend factoring. But we're still going to do the quadratic formula just so you can see how it works. So first off, the very first thing you should always do with the quadratic formula is list your A, B, and C values. So you know exactly what you're plugging in. So what's my A value? 2. What's my B? C. All right. Now, I'm just going to put the quadratic formula over here just so we can reference it. All right, that's the quadratic formula. So now I'm going to put everything in the formula. So I'm going to replace all the letters with the numbers that I already stated equal those letters. But I'm going to do no simplifying yet. All right. So I'm not going to jump the gun and do any simplifying. So this is -11 plus or minus the square root of 11 squared minus 4 times 2 times -6 all over 2 times 2. So all I did was put the numbers straight into the formula. I've done zero simplifying. Now, what I usually tell my kids when dealing with a quadratic formula, deal with what's under the radical first. All right, so whether that's putting it in your calculator to get it or just doing a quick kind of check. So this is the same thing as -11 plus or minus the square root. What's 11 squared? 121. And then what is -4 times 2? Plus times -6. Positive 48. All over. And then what's 2 times 2? 4. Then, still simplifying what's under the radical, this would be -11 plus or minus the square root of 169 all over 4. Well, is the square root of 169, is 169 a perfect square? What is the square root of 169? 13. So this is -11 plus or minus 13 all over 4. Now, since we completely got rid of our radical, we now need to break apart this plus or minus like we did when we were completing the square. So I'm going to break this apart into -11 plus 13 over 4 and -11 minus 13 over 4. So imagine that these have parentheses around them, so you would do it that first. So this would equal 2 over 4, which simplifies down to what? 1/2. This would equal -24 over 4, which simplifies down to what? -6. So these are our two answers. So x still equals the set of positive 1/2 and -6. So even though we did it in two different methods, we still got the exact same answers. So we already know factoring is easier, but how do we know if it's worth to even try to factor it? What do we always start with? Well, we know it's saying equal to 0, but how do we start by solving by factoring after we said equal to 0? You would multiply the A times C and look at the B value and see if it's even possible to come up with factors that would add to that. All right. So for example, if I looked at the one on the previous page, if I did A times C, that would give me 1. 1 times 1 is 1. Is there any way I could find numbers that would add up to -6 for factors of 1? No. So that's an easy way to tell if it is factorable or not. All right. So do A times C and see if it is possible to find factors to add to B. Because a lot of times, just when you multiply A times C, depending on what the B value is, a lot of times you can just eyeball and say, yeah, there's no way. All right. So now we're going to do some problems that we definitely can't factor. So let's look at the next page. So they restate the quadratic formula for us. We're going to go through and do all of these. So, first things first, we always start by listing your A, B, and C. Now, you guys are honors, so do you necessarily have to do this every time? No. But do I think it's a good practice to do? Yes. Because I can't tell you how many times, because I was an honors kid growing up, I can't tell you how many times I have accidentally plugged in an A for a B value. All right. So sometimes just having that list in front of you will take away those mistakes. All right. So what's my A value? B? And C. Okay. So I'm just going to put it straight into the formula. So -5 plus or minus the square root of 5 squared minus 4 times 3 times 2 all over 2 times 3. So I just put it in the formula. I have not done any simplification. So now that we are simplifying, let's start with what's under the radical first. So I'm going to rewrite this as -5 plus or minus. What's 5 squared? 25. What's -4 times 3? So -12 times 2, -24, yes. All over 6. And then what's 25 minus 24? 1. So this would be -5 plus or minus the square root of 1 over 6. Well, what's the square root of 1? 1. So this is -5 plus or minus 1 over 6. So we got rid of the radical. So our last step is to separate that plus and minus. So I have -5 plus 1 over 6, -5 minus 1 over 6. So what's -5 plus 1? -4 over 6. So that simplifies down to what? -2/3. What's -5 minus 1? -6. So -6 over 6 does simplify down to -1. So x equals the set of -1 and -2/3. Any questions on that one? Let's try another one together, and then I'll have you guys try some on your own. So this next one, first off, this one's definitely not factorable because what's 1 times 13? Is there any way we can come up with factors of 13 that add to -8? Nah, 13's prime anyway. So list my A, B, and C first, just so I have that list. So it's A, 1, B, C. Good. Now, remember, in the quadratic formula, the negative at the beginning is part of the formula. So when we multiply the -8 to it, we have to do a negative times -8. So even though the 8's already negative, we still got to apply a negative to it. Plus or minus the square root of -8 squared minus 4 times 1 times 13 all over 2 times 1. So if I simplify what's under the radical, first off, what's a negative times a negative 8? Positive 8. So this would be positive 8 plus or minus the square root. What's negative 8 squared? 64. And then what's negative 4 times 13? Yeah, it's 52. So, and then it's all over 2 times 1, which is just 2. Now, this will be 8 plus or minus the square root of 12 all over 2. Well, we know that the square root of 12 is not a perfect square. However, what have we been learning to do with radicals? Simplify them. So I got to simplify this radical right here. So what does 12 break down into? 4 and 3. So this would be the square root of 4 times the square root of 3, which is what? 2 square root of 3. So 8 plus or minus 2 square root of 3 all over 2. Now, we're not quite done simplifying yet. If all three numbers, not including what's under the radical, can be simplified, then simplify them. Yes, so the 2's will cancel out, but you're technically doing 8 divided by 2 and 2 divided by 2. All right? So that's why I say look at it in terms of simplifying. If all the numbers can simplify, besides the number under the radical, simplify it. So what's 8 divided by 2? Plus or minus, what's 2 divided by 2? 1. So we'd have the square root of 3. And then 2 divided by 2 is still 1, so we put it over 1, so we're done. Now, this would be the same thing as 4 plus square root of 3, 4 minus square root of 3, but since we can't simplify it further, we just leave it like that. No. Because you cannot combine the 4 and the 1 here because of that square root of 3 next to it. All right, do I need to do another one with you guys? All right, try C and D on your own. So try C and D on your own.
You could just do 1 plus root. So since these have the same, then you can just leave it as 1 plus or minus root. Yeah. Yeah.
You're right there. Give me 1 second.
times negative five is just like it would be negative four times two is negative five. So four plus four.
It's a negative three, it's equal to negative. This is a positive.
That's a positive number, but because you included that negative. So if you put the string in because they did negative four times two times negative five, which is 40.
Or when they go down.
No, because I took the negative from the 40. So if I do 4 times 2 times negative 5, negative 40. What's the negative times negative? Negative 1 plus negative 1. Just add these two together. So there should be. So so it shouldn't make 4 plus 4. So 4 plus 4. So another one. There's 2 right there. There you go. It's like you have the wrong numbers. Wait, mine's too. Oh wait, maybe it is negative 1. You got because you have to put that on negative 2. If you don't, it reads as negative 1 times 2 squared. Same thing with your calculator.
Negative 2 squared.
So I have that in my answer right now.
All right, guys. So for time's sake, we're gonna move on. So here's what I got. All right. So check your answers.
see, if you got 2 plus or minus the square root of 11, would that still be right?
2 plus or minus the square root of 11? No. So you had to simplify all three numbers. So it would be 1 plus or minus the square root of 11 all over 2.
Yeah, I just simplified. I did the. When you get 11 though for the first, then you have for 44 over 4.
Yeah, so it'd be 2 square root 11, which I got right here. And then I had to simplify these three numbers.
Go away.
No. Because if you think about it, 2 over 4, what's that simplify down to? Same thing here. 2 over 4 simplifies down to 1/2. All right, any other questions on these? Okay, now go back to that green paper. Look on the back side. So the last thing I want to talk about, and then we're done, is quadratic formula where you get imaginary numbers. So complex roots. All right, so in other words, you're going to see I again. So remember when we talked about I? When does I come into play? Right, square root of -1. So in other words, you have a negative under your radical. That's when you take those i's out. All right. So we're going to do at least 2 examples together quickly. So ABC, what is it? 1, -8, 25. So this would be negative b, so -8 plus or minus the square root of b squared, so -8 squared minus 4 times a, which is 1, c, which is 25, all over 2 times 1. So do some simplifying. I get 8 plus or minus the square root. -8 squared is what? 64. -4 times 1 is -4 times 25 is -100. All over 2. Now, just by looking at this, what do you think is going to happen under that radical? We're going to end up with a what? A negative number. So this is equal to 8 plus or minus the square root of -36 all over 2. Which means, since we have a negative under the radical, we automatically have to do what? Take out that I. So I have 8 plus or minus I, square root 36 over 2. What's the square root of 36? 6. So I have 8 plus or minus 6i over 2. Now, or plus minus, not plus. Now, we still can simplify all of these because it's pretty much the exact same thing as 8 over 2 plus or minus 6i over 2. All right, that's another way you can think about when you simplify those numbers. So, what's 8 divided by 2? 4 plus or minus, what's 6i divided by 2? 3i. So that's our answer. And those are both answers because remember we can separate to 4 plus 3i, 4 minus 3i.
Why do we have to add the I in there? Like after 8 plus or minus the square root of 36 over 2.
Because we had that negative under the radical, we had to take that I out to make it positive. Because remember the square root of -1 is I. So basically, if you ever see a negative under a radical, after you evaluate all the addition subtraction, automatically take the I out. 4 plus or minus 3i. Any questions on that one? Yeah, this will be on the test. All right, now, last one I want to do is number 3. All right. So, number 3, ABC. That'll be 4, 17, 19. So I have negative 17 plus or minus the square root of 17 squared minus 4 times 19 all over 2 times 4. Now, if I do some simplifying, this is negative 17 plus or minus the square root. What's 17 squared? 289. And then what's negative 4 times 19? So in other words, negative 16 times 19. So someone, their calculator, do negative 16 times 19. Negative 304. All over 8. So we need to simplify still what's under the radical. So what is, good, negative 15 all over 8. So we have a negative under the radical. So what's our first step? Take that I out. So I have negative 16 plus or minus I square root 15 over 8. Now, square root 15, are there any perfect square factors in it? No, just 3 and 5. So since negative 17, I, and 8, so negative 17, 1, and 8 have nothing factor-wise in common that we can simplify out, we're done. So that's our answer. And I would literally just leave it like that. Yes. Mm-hmm. All right. So I would still hold on to that green sheet because it is notes. All right. But your homework is a delta math. Okay. So it covers everything. So stuff with I in it, the radicals, all that. I made you Monday. So I gave you guys a whole weekend because quadratic formula is fairly difficult. Also, my suggestion is work through some of the review tonight and come to me with questions tomorrow. All right, I will go to it later as well. Yeah, you can have So guys, you still got a solid 10 minutes. So find something to keep you occupied, but